Hello everyone, welcome to new class. Let us study about signal flow graph. The signal flow graph is used to represent the control system graphically. And it was developed by S.J. Mason. A signal flow graph is a diagram that represents a set of simultaneous linear algebraic equations. By taking Laplace transform, the time domain differential equations governing a control system can be transferred to a set of algebraic equations in S domain. And the advantage in signal flow graph over the block diagram approach is that in signal flow graph method, using Mason's gain formula, the overall gain of the system can be computed easily. And a signal flow graph consists of a network in which nodes are connected by direct branches. And each node represents a system variable. And each branch connected between two nodes act as a signal multiplier. Each branch has a gain or transmittance. When the signal passes through a branch, it gets multiplied by the gain of the branch. And the signal flows in only one direction. The direction of signal flow is indicated by an arrow placed on the branch, and the multiplication factor is indicated along the branch. The terms used in signal flow graph are node. A node is a point representing a variable or signal. Then branch. A branch is directed line segment joining two nodes. Then transmittance. The gain acquired by the signal when it travels from one node to another is called transmittance. The transmittance can be real or complex. Then input node or source. It is a node that has only outgoing branches. Then output node or sink. It is a node that has only incoming branches. Mixed node. It is a node that has both incoming and outgoing branches. Then path. A path is a traversal of connected branches in the direction of the branch arrows. The path should not cross a node more than once. Open path. An open path starts at a node and ends at another node. Closed path. Closed path starts and ends at same node. Forward path. It is a path from an input node to an output node that does not cross any node more than once. Then forward path gain. It is the product of the branch transmittances or gains of a forward path. Individual loop. It is a closed path starting from a node and after passing through a certain part of a graph arrives at the same node without crossing any node more than once. Then loop gain. It is the product of the branch transmittances of a loop. Then non-touching loops. If the loops does not have a common node, then they are said to be non-touching loops. Next is properties of signal flow graph. The basic properties of signal flow graph are algebraic equations which are used to construct signal flow graph must be in the form of cause and effect relationship. Then second one, signal flow graph is applicable to linear systems only. Third one, a node in the signal flow graph represents the variable or signal. Fourth one, a node adds the signals of all incoming branches and transmit the sum to all outgoing branches. Fifth one, a mixed node which has both incoming and outgoing signals can be treated as output node by adding an outgoing branch of unity transmittance. Next, a branch indicates functional dependence of one signal on the other. Next, the signals travel along branches only in the marked direction, and when it travels, it gets multiplied by the gain or transmittance of the branch. The last one, the signal flow graph of system is not unique. By rearranging the system equations, different types of signal flow graph can be drawn for a given system. Next is signal flow graph algebra. The signal flow graph for a system can be reduced to obtain the transfer function of the system using the following rules. First one is incoming signal to a node through a branch is given by the product of a signal at previous node and the gain of the branch. So here x1, x2 are the variables and a. Here a is the or a1, a2, these are the gains. So here we can write x2 is equal to a into x1. Similarly here this x3 is equal to x1 into a1 plus x2 into a2. Then second one, cascaded branches can be combined to give a single branch whose transmittance is equal to the product of individual branch transmittance. So here there are two branches in cascaded form. That is, this is one branch, this is next branch. So these two branches we can combine to one branch where this gain is equal to the product of these two gains, that is A into B. Then third one, parallel branches may be represented by a single branch whose transmittance is the sum of the individual branch transmittance. So these two are in parallel form, so we can combine into single branch by adding the transmittance, that is A plus B. Then fourth one, a mixed node can be eliminated by multiplying the transmittance of outgoing branch to the transmittance of all the incoming branches to the mixed node. So this is a mixed node, that is here incoming and outgoing branches are there. So this is a mixed node and this can be eliminated by multiplying the transmittance of outgoing branch to the transmittance of all incoming branch. That is, here we can multiply like this and multiply like this. So we get like this, that is A into C here, then A into B into C here. So this mixed node we can eliminate. The last one is a loop. So this is a loop. A loop may be eliminated by writing equations at the input and output node and rearranging the equations to find the ratio of output to input. And this ratio gives the gain of resultant branch. So here this is a loop and this loop we can eliminate like this, that is B divided by 1 minus B into C, and we can combine these two like this, that is these two are in cascaded form, so we can write A into B divided by 1 minus BC. Next is signal flow graph reduction. The signal flow graph of a system can be reduced either by using the rules of a signal flow graph algebra by writing the equations at every node and then rearranging these equations to get the ratio of output and input, that is to get the transfer function. And this method is time consuming, and we have another method, that is by using the Mason's gain formula. So let us study about Mason's gain formula. So this Mason's gain formula is used to determine the transfer function of the system from the signal flow graph of the system. Let R of S equal to the input to the system, then C of S equal to output of the system. Then we have the transfer function T of S equal to C of S divided by R of S. Then the Mason's gain formula states the overall gain of the system, that is overall gain T is equal to 1 by delta sigma k pk delta k, where T is the transfer function of the system, then pk is the forward path gain of kth forward path. Then delta is equal to 1 minus sum of individual loop gains plus sum of gain product of all possible combinations of two non-touching loops, then minus sum of gain products of all possible combinations of three non-touching loops plus etc. Then delta k is equal to delta for that part of the graph which is not touching the kth forward path. So this is the Mason's gain formula to find the overall gain or overall transfer function of the system. Next is constructing signal flow graph for control systems. So a control system can be represented diagrammatically by signal flow graph. The differential equations governing the system are used to construct the signal flow graph. By taking Laplace transform, the differential equations can be converted to algebraic equations. The constants and variables. Constants and variables of the equations are identified. Then the variables are identified as input, output and intermediate variables. For each variable, a node is assigned. A node is assigned in signal flow graph, and constants. Constants are the gain or transmittance of the branches connecting the nodes. Then for each equation, a signal flow graph is drawn and then they are interconnected to give overall signal flow graph of the system. Next is the procedure for converting block diagram to signal flow graph. First one is assume nodes at input, output, at every summing point, at every branch point and in between cascaded blocks. Second one, draw the nodes separately as small circles and number the circles in the order 1, 2, 3, 4, etc. Third one, from the block diagram find the gain between each node in the main forward path and connect all the corresponding circles by straight line and mark the gain between nodes. Then fourth one, draw the feed forward path between various nodes and mark the gain of the feed forward path along with sign. Fifth one, draw the feedback path between various nodes and mark the gain of feedback path along with sign. So this is the procedure for converting block diagram to signal flow graph. So let us do the problems in the next class, that is using the signal flow graph to find the transfer function. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.